Hello everyone, today we're going to teach you of the hyperbola. My teammate is Mariana Castillo and my name is Omar Garza. Okay, so let's get to it. The hyperbola is a type of smooth curve lying on a plane. It is defined by its geometric properties or by equations for which it is a set of a solution. The hyperbola looks alike like the parabola. The hyperbola is one of the three kinds of conic sections, and in those three kinds of conic sections, one is the parabola, the second is the ellipse, and the third one is the hyperbola. Why do they look alike? First of all, imagine two cones with the tips of each one intersecting. So you'll have like a cone like this and another one like this. If you cut one cone perpendicular, you'll have a parabola. If you cut it vertically and you do not go through the, let's say, the axis or the point of connection between those two, you'll form a hyperbola. And if you cut it horizontally through let's say not the vertex, the meeting point, that's an ellipse. But today we're going to talk about hyperbola. Okay, so the hyperbola has two pieces called the connected components or branches, and those are mirrors of each other and resemble to infinite balls. That's why you can see, like, if you have the cones and you cut it through them, if you have like the remaining volume, you can see of it as a ball. And also, if the plane intersects both halves of the double cone but does not pass through the apex of the cone, then the cone is a hyperbola. That's what I said before. So hyperbolas can arise in many ways. As a curve representing the function like f of x equals 1 over x in a Cartesian plane. Okay, so now that we've told you this, let's get it a little bit more concise if you didn't get it. So a hyperbola, it is a set of points in a plane such that the difference of the distance of each point of the set from the two fixed points, called foci, how you want to call it, in the plane is constant. Okay, so a hyperbola is made up of two separate parts. The transverse axis, that is, contains a foci.
So a hyperbola is, we're going to sketch it here, is the x-axis, the y-axis. So a hyperbola are two line segments that are curved, something like this, where they stay in two asymptotes that make a cross line through the x and y axis. Meaning that the vertices of those two lines make a transverse axis. There are 2 points that are in the middle of the two curves, of the two hyperbolas, that are in the center of two of them. They are called focus. And between those two, and between the two vertices, is located, give us a center of -2,3, where the x is 2, -2, and 3, changing to positive here. So with this, we have to take out the vertices. So the vertices, we take them out with the lead. The y-axis is the lead. So to take out the vertices, we have to use the a squared. For that, we're going to add and subtract to the y-axis 1. So it's going to be 3 plus 1 and 3 minus 1 to the y-axis. And also we're going to use the foci. As I already explained, the foci is the center of the two hyperbolas in the x-axis. So we are also going to add to the y-axis, but we're going to add the c, that is plus the square root of 10 minus the square root of 10. So our vertices are going to be -2, 4 and -2, 2. These are our two vertices. And for the slope, we are going to use the y over x. That is what I remember, where y is equal to 1 and over -3. So this is our slope. It is plus minus 1/3. So this is where the asymptotes are. So we already have the two vertices and the two asymptotes. So let's go and try to graph it. The two asymptotes doesn't make a part of the hyperbolas, but it shows that both hyperbolas go infinite, either this way, this way, this way, and this way. And these are the asymptotes. How to take the hyperbola with the centers h and k.
Hello, it's me again. Now that my partner Mariana has told you the basics about the hyperbola, I'm going to give you some real-life examples so you can identify them when you see them. Okay, the first that you're going to look at, and believe me when I tell you this one, you'll want to try it, sorry, is a lampshade. Yeah, a lampshade. I took this photo right now. It's of a household lamp and it casts a hyperbolic shadow on a wall. That's probably the most basic, but the one that most people are not aware of. The second one is a sonic boom. If you haven't seen a military jet going over Mach 1, that's faster than the speed of sound, when they break through that speed, they create like a cloud in the back of the plane. That's called a sonic boom. So it's something like this. As you can see, as the plane moves faster than the speed of sound, you get a cone-like wave, here it is, where the cone intersects the ground. It's a hyperbola. So the sonic boom hits every point on that curve at the same time. No sound is heard outside the curve. The hyperbola is known as a sonic boom curve. And that's the second one. So also, the third one, if you have went I think it's Rio Verde in Veracruz, we have a nuclear plant over there, but we do not have like cooling towers. But in the US, if you have went and seen a cooling tower of a nuclear reactor, it's something like this. So as you can recall from the past two pictures, you might know why this has also like the design of a hyperbola. So this is due to the fact that the structure must be able to withstand high winds, and they should be built with as little material as possible. So when they build it with like a hyperbola, these sections on the sides were cut off and that material was saved, so it might save like millions of dollars. Also, due to this shape, the structure was stronger. So those are basically the most basic real-life examples of a hyperbola. So we hope you liked our video and you learned something. Thanks.